Hello, everyone. So, today we're going to cover an important topic. So important, we're going to be using it almost in every single question throughout the entire geometry year. And that is the idea of parallel lines and what they tell you about angles. So, there is no way to prove that this is true really other than intuition. You can draw parallel lines and measure the angles and stuff, but we will just assume that this set of facts is true. That two angles formed when a transversal intersects two parallel lines come in two groups of four equal angles as shown. A, B, C, D. E, F, G, H. Those are the two groups of four. Now, when it's referring to a transversal, it's referring to this line. That's your transversal. The transversal is the line that is intersecting your two parallel lines and hence creating these angles in the first place. Now, the special property that these angles have is that a lot of them are the same. For example, A is equal to C is equal to E is equal to G. B is equal to D is equal to F is equal to H. And another nice fact is that anything in the first set, so the first set being this one, is supplementary to the second set, which means that anything from this first one plus anything from the second one must add up to 180. For example, A plus F must be 180. If the two angles are not the same, they must add up to 180. So, you really only have two distinct measures of angles. The first set and the second set. Now, you could have a situation where all the angles are equal, but that would just be if it was a 90-degree line, a perpendicular line going through them. Then every angle A, B, C, D, all the way to G would be equivalent to 90. Anyway, all that being said, let's see an example. So, lines M and N are parallel, and we are given the measure of one angle in the diagram as shown. Find the values of ABC, WXY, and Z. Okay? Well, because of some of the properties we should be familiar with, the angle B must be equivalent to 35 degrees because they're vertical angles. So B, you can even say the measure of angle B is 35 degrees. Okay? Now, the angle A and the 35-degree angle are both what we call a straight angle, because if you took that entire measure, it would be the entire top half of that straight line, or you could think of it as a semicircle. So, what must the measure of angle A be? The measure of angle A is going to be equal to, well, if it's not 35, it must be supplementary with 35. Hence, add up to 180. So if we take 180 minus 35, we will get our measure. So the measure of angle A, well, 180 minus 30 is 150, minus 5, 145. And honestly, with those two alone, now that you know what the two pairs of angles are, all the rest is fairly simple. So C is going to be the exact same thing as A, and then you can kind of just transplant the group this first group ABCD or ABC 35 into the second group WXYZ. But there are special terms that we would like to know, like the fact that angle B and angle X are going to be the same because there's something called alternate interior angles. Spelling that wrong already, but alternate interior angles. And what do I mean by that? Well, if we look at our two parallel lines and imagine, I'm just going to just take up all the space on the inside, the interior. That's what it means by interior. Alternating means different sides of the transversal. So B, if we look at angle B, is on a different side of the transversal as X. Hence alternate interior angles. And they just happen to have this property where alternate interior angles are the same. This is just something super important to remember. Also, X must be 35 because these X and the 35 are in what's called corresponding positions, or the same positions. Corresponding angles are also the same. So that lets us know that angle X is also 35 degrees. Well, we can then figure out that, well, angle Y is 35 because it's a vertical angle with angle X. And now similar logic can just get us the rest. So C and W are alternate interior, so therefore W must be 145. And W and Z are alternate, vertical angles, so they must be 145 as well. And that gets you every single angle measure on there. And if we were to put it all together, it would look something like this: 145, 145, 35, 35, and so on. Only two unique angles in the whole thing. And there you have it. It is that simple. But this simple idea has a lot of larger consequences that we will see in the future.